students, welcome to today's session. Till now, we have seen various concentration terms like molarity, molality, percentage composition, mole fraction, ppm and ppb. Today, we are going to see a very important concept of relation between concentration terms, and we'll be solving many numericals on this. In exam, if you know this direct formulas of solving the relation between concentration terms, it becomes very easy. It's not that you cannot solve the numericals without this formula, but it is little time consuming in the exam, and writing every detail, doing it using different formula will take a lot of time in the exam. So to save your time, so this formula will be of lot of use. Now we have three categories in this. The first will be relation between molarity and percentage weight by weight. The next will be relation between molality and mole fraction, and the last one is relation between molality and molarity. Now I will go according to the symbols. You people know molarity is capital M, molality is small m, and mole fraction is your chi. Okay, mole fraction is your chi. Now here it is small m and here it is our capital M. Now let us try to write a formula for this. Okay, relationship between molarity and percentage weight by weight. Okay, what is the formula? Molarity is equal to 10 into percentage weight by weight into density divided by molecular weight of B. Now whenever I use B here, alphabet B, it is for solute, and whenever I use alphabet A, it is for the solvent. B is for solute and A is for solvent. Now if you now what will be this? Okay, M is for molarity, you people already know. Okay, percentage weight by weight of the solution. Okay, what is percentage weight by weight? This is percentage weight by weight of the solution. Now what is D? D is the density of the solution. D is the density of the solution. What is M? Molecular weight B means it is molecular weight of solute. Molecular weight of solute. Okay, so using this formula, you can calculate the relationship between molarity and percentage weight by weight. Means if one concentration term is given in the exam, it is very easy for you people to know about the other concentration term. So this is the formula to deduce the relationship questions between molarity and percentage weight by weight. Now let us see the next formula. Okay, a relation between molality and mole fraction. So what will be the formula here? Molality is equal to chi B divided by chi A into 1000 divided by molecular weight of A. I just now told you whenever I use B, it is about the solute. Whenever I use A, it is about the solvent. Okay, now what is chi B? Chi B is equal to mole fraction of solute. Chi B is mole fraction of solute. Chi A is equal to mole fraction of solvent. Okay, and MW, molecular weight of A, means that it is equal to molecular weight of solvent. So small m is molality. So small m is equal to chi B by chi A into 1000 by molecular weight of A. We use this formula to get the relationship between mole fraction and molality in the question. So if they give about mole fraction, it is easy for you to know about molarity. If they give about molality, it is very easy for us to get a understanding about the mole fraction. Now any quantity in this you can find out. Like you get a better understanding of how do we apply these formulas when I start teaching you numericals. Now the next relation is relation between molality and the molarity. Okay, how to write this? So molarity is equal to M into D divided by 1 plus M into molecular weight of B divided by 1000. Now each and every term, what is that? If you are getting confused, I will write here. Capital M is molarity, small m is molarity. This you people already know. Okay, now what is D? D is equal to density of the solution. Okay, MWB is equal to molecular weight of solute. Okay, capital means small m, you already know they are molarity and molarities. Small d is density of solution. MWB is molecular weight of the solute. As I told you, whenever it is capital B, it is about your solute. So these are the three formulae which we use to calculate the numericals, in which more than one concentration term is used. Okay, so now let us see many numericals, okay, to give a better understanding of how to use these formulae and make our numericals very easy in the exam, and how to save a lot of time in the calculations. At least, if there is a numerical, instead of using 2-3 formulae, if the things are happening with one formula, it is well and good. So let us see numericals under this category. So we'll do many numericals. So let's start solving numericals on relationship between concentration terms. Let us solve numericals on this concept. A solution of HNO3 of density 1.4 gram per ml and 63% weight by weight composition. Determine the molarity of HNO3 solution. Now here in the question I have been given percentage weight by weight, and I have been given density, and asking to find out the molarity of HNO3 solution. So we have the relationship formula between molarity and density and percentage weight by weight. What is the formula? Molarity is equal to 10 into percentage weight by weight into density divided by molecular weight of, what is the molecular weight of solute? So it is solute here, HNO3 molecular weight you have to find out. Okay, so if you substitute it, okay, what is given in the question? Okay, 10 into percentage weight by weight of the solution is given. Okay, what is the percentage composition of the solution here? 63. 63 into what is the density of the solution given in the question? It is 1.4 gram per ml. How much is the density? Density is 1.4 gram per ml divided by molecular weight of B. What is the solute here? It is a solution of HNO3. So solute is HNO3 and the solvent is water. So calculate the molecular weight of HNO3. HNO3. Hydrogen, hydrogen mass is 1. Nitrogen, it is 14. Oxygen, 1 oxygen is 16. So 16 3 is a 48. Okay, it comes to 63, okay, divided by 63. Now if you see, the calculation is very easy here. 63 and 63 gets cancelled. So how much you will get here? 14. So what is the molarity of HNO3 solution? Molarity of HNO3 solution is equal to 14. What is the unit of molarity? Okay, either write it as 14 molar or write it as 14 moles per liter, because the unit of molarity is moles per liter. See how quickly you are able to solve the question. Okay, instead of that, if you are trying to expand 63% weight by weight as 63 grams of HNO3 present in 100 grams of solution, from that you will try to get the information for the molarity. So all this, okay, again from density you will try to get the volume information for molarity. All this is very time consuming. So if you have this formula in your mind, it is not like you can't do with those formula, but this formula will save your time in the exam. Okay, now let us see the next question. Find mole fraction of B, means mole fraction of solute, of 1 molar aqueous solution. So molality is given. They are asking me to find the mole fraction of one component, which is the solute. What is the formula I have for mole fraction and molality? Let us write the formula now. Okay, molality is equal to, okay, here we need the formula for molality and mole fraction. So what is the formula? I told you molality is equal to mole fraction of solute divided by mole fraction of solvent into 1000 divided by molecular weight of solvent. Here molality of the aqueous solution is already given to me, and what do I need to find out here? I need to find out XB, which is the mole fraction of solute. I will not write again and again XB is mole fraction of solute, because I already told you whenever I am using B, it means I am talking about the solute. Now I can substitute whatever terms I have here. Molarity is 1 here. Now mole fraction of solute I need to find out. Do I need to find out mole fraction of solvent? No. But even if I find one, other is very easy. Can I write mole fraction of A as 1 minus XB, because we want XB. I want everything to be in terms of okay, for your convenience I am calling it as XB, but you should not call it as XB. You should call it as chi B. So this term basically is what? Chi. So just for our convenience we keep writing like that, but you should be calling it as chi. Okay. Okay, I am writing XA in terms of XB, because ultimately I need XB, I don't need XA here. Okay, and so because for me XA is not given, it is very difficult for me to solve keeping XA here. So I'm just converting XA in terms of XB. And you people know XA plus XB is equal to 1. So XA is equal to 1 minus XB. So that logic I'm using here. Okay, into 1000 divided by, okay, if it is aqueous solution, when we say it is aqueous solution, what is the solvent here? When we are talking about aqueous solution, the solvent should be water. So what is the molecular weight of water? You know, molecular weight of water is 18. Okay, so 1000 divided by 18. Okay, so this is how I got it. Now we already know, we already did this calculation many times. Okay, we already did this calculation many times. 1000 divided by 18 will come to 55.5. We already know that calculation. So okay, so how much this will be? This will be 1000 divided by 18. Okay, 1000 divided by 18, because we did this calculation in the in the previous calculation many times. So I'm writing directly. Okay, 1 is equal to XB divided by 1 minus XB into 55.5. So I can do the cross multiplication here. So what will I get from here? 1 minus XB is equal to XB into 55.5. Okay, 55.5. So I can take this XB term over there. So what do I get here? I can take this XB over there. So it will be, okay, it will be what? Okay, let me take this XB over there. Then it will be XB plus XB into 55.5 into 50, okay, plus XB into 55.5, which is equal to 1. Okay, which is equal to 1. Now I will write it neatly, XB. Okay, now from here what do I get here? Okay, 55.5 XB plus 1 XB. This I can take it as 1 XB will be what? 56.5 mole fraction of B, chi B. Okay, which is equal to 1. But however you are comfortable, you call it. Okay, 56.5 chi B is equal to 1. So what will be the value of chi B here? Chi B is equal to 1 by 56.5 is my mole fraction of the component A. Is the mole fraction of my, is the mole fraction of my component B, which is my solute. So what is the answer here? 1 by 56.5. Okay, this is how you solve the equation and get chi B. Now I think you people understood why did I take chi A in terms of chi B, because ultimately I need chi B and I don't have the value of chi A in the question. Now if you want, you can calculate chi A also, because you know 1 minus chi B will give you chi A, but it is not asked in the question, so I am not doing it. So this will be my answer. Okay, let us see this question now. A solution of H2SO4 is 98% H2SO4 by mass. So he has given percentage weight by weight, and the density is 1.8 gram per ml. Okay, volume of acid required to make 1 liter of 0.1 molar H2SO4 solution is. This is a very beautiful question. If you see this question, okay, initially he has given a solution of H2SO4 whose weight by percentage weight by weight he has given and density he has given. Okay, he is asking me volume of acid required to make 1 liter of 0.1 molar H2SO4 solution. Now, this is my motto, this is my goal. Which type of solution should I get? I should get a solution which is 1 liter in volume and 0.1 molar, okay, in molarity. Okay, now this is my final solution. Now this is my initial solution. From this solution I have to make this solution. Clear? Now I need volume of acid required to make this much. So if I know, okay, if I calculate molarity from here, if I calculate molarity from this data, okay, if I calculate molarity from this data, that will be molarity before dilution. So from there I get molarity before dilution. Okay, I already have molarity and volume after dilution. So I can get volume before dilution. Am I right? I can get volume before dilution. So he has given this first data so that you calculate molarity of initial solution of H2SO4. Okay, whose volume we don't know. Okay, whose volume we don't know. How are we going to calculate the initial volume? By making use of its final volume and final molarity. So first, okay, let me write the data. M1 we don't, okay, M1 we can calculate, okay, M1 is yet to be calculated. V1 he is asking us in the question, okay, V1 he is asking us in the question. M2, what is the final molarity? It is 0.1 molar. And what is the final volume? It is 1 liter. Okay, first let me calculate M1 using the information I have. I have percentage weight by weight and density. So which formula of molarity can I use here? I can use this formula. No, molarity is equal to 10 into percentage weight by weight into density divided by molecular weight of the solute. Divided by molecular weight of the solute. So whatever data I have, I'll write here 10 into percentage weight by weight is how much here? 98 into density is how much? 1.8 divided by molecular weight of H2SO4 is 98, but we'll quickly see. Okay, 2 hydrogens here, so weight will be 2, 1 sulfur weight will be 32, 4 oxygens, 1 oxygen weight is 16, so 4 oxygens weight is how much? 64. If you add, it will come to 98. So let me substitute this 98 here. Okay, now the calculation is very easy. Most of the time in exam, even the paper setter understands that you have time limit in the exam. So he will give the numbers in such a way that your time is judicially used. So he will not give so big, but sometimes he might give, but most of the times they'll try to give in such a way that you can solve it in less time only. Okay, 98 gets cancelled, 1.8 into 10. So molarity is equal to how much? 18 molar or 18 moles per liter. Okay, now I have the molarity of the H2SO4 which is initially taken. Okay, but I don't know the volume of the H2SO4 I have taken initially, whose molarity is 18 molar. But I have diluted this. I have diluted a solution of H2SO4 whose molarity is 18 molar. I have diluted that solution. When I diluted the solution, the final molarity has come to 0.1 molar and the final volume has come to 1 liter. But I don't know what is the initial volume of the solution. Okay, I know the molarity of the initial H2SO4 solution I have taken, but I don't know its volume. So I need to calculate its volume. Now I taught you in the previous sessions only how do we calculate molarity on dilution and what is molarity on dilution. So what was the formula which we can use here? M1V1, which is before dilution, is equal to M2V2 after dilution. So this will be before dilution and this will be after dilution. So I have M1 here, 18 molar. V1 we need to calculate because we don't know what is the volume of H2SO4 initially taken. Final molarity is equal to 0.1 and final volume is equal to 1. Okay, from this we can get V1 value. So V1 is equal to 0.1 divided by 18, that is equal to 1 by 180. Okay, I have calculated up to here. You people are very good in math, so you can further convert, do this division part. Okay, do this division part and get the answer. Okay, and get the answer, and please take care that the answer should be written up to, okay, up to how many decimal points? Up to 2 decimal points. Up to 2 decimal points. Okay, do this calculation, do this division and write the answer up to 2 decimal points. Okay, so this is how you calculate any numerical in the exam where you get two or more concentration terms in the question. Usually you get only 2 concentration terms in the question. Little bit here and there you will link certain things. So as long as you have this formula on the tips, it saves your time so much in the examination and you will feel that the question is such easy. Okay, if you don't know the formula, it is not a lengthy process. Still you can do it, but it takes time. If you don't get time to do calculation, unnecessarily you will be losing marks in such easy questions. Okay, we will not stop here. For even better understanding, we will do few more numericals on this concept. Let us solve few more numericals on this concept. The density of the solution prepared by dissolving 120 grams of urea in 1000 grams of water is 1.15 gram per ml. The molarity of the solution is, I have a solution whose density is given to me, which is 1.15 gram per ml, and this solution is prepared by dissolving 120 grams of urea, which is my solute, in what amount of water am I dissolving it? 1000 grams of water, which is my solvent. I need to find the molarity of this solution. Now, if we go back to the formulae for the relation between concentration terms, if I need molarity and if density is given and percentage weight by weight is given, I can easily calculate molarity. Density I have, it is directly given, but percentage weight by weight is not directly given, but I can calculate percentage weight by weight first and then go to molarity. Okay, and then go to molarity, because molarity formula will be what for me here? 10 into percentage weight by weight into density divided by molecular weight of B. Okay, which is molecular weight of solute. Here I have all other things. I have density, molecular weight of solute I can calculate because I already know it is urea. Okay, using urea formula I can calculate. So what is the information which I don't have here? Percentage weight by weight. So let me calculate percentage weight by weight. Okay, that is equal to weight of solute or mass of solute divided by weight of solution into 100. Now how much is weight of solute given here? 120 grams. 120 divided by, what is the weight of solution? Weight of solution is not directly given, but I can get it by adding weight of solute plus weight of solvent. 120 plus 1000 will be 1120. Okay, will be 1120 grams. 1120 into 100. Okay, this 0 gets cancelled. So how much will I get here? 1200 divided by 112. Now here I have all the data. I can start substituting now, but I need to calculate the molecular weight of the solute. Here molecular weight of solute is molecular weight of urea. Urea formula is NH2CO NH2. Okay, NH2CO NH2 is the formula of urea. It will be 60, but still I will calculate and show you. Nitrogen is 14, 2 hydrogens it is 2, carbon is 12, oxygen is 16, nitrogen is 14, 2 hydrogens it is 2. If you calculate and check, it will come to 60. Okay, if you calculate and check, it will come to 60. So molecular weight of urea is equal to 60. Now I have all the data with me, so let me start substituting them. 10 into what is percentage weight by weight? Okay, 1200 divided by 112. So I'll put 112 in the denominator here. Into density is how much? 1.15. Okay, into molecular weight of solute will be 60. Okay, molecular weight of solute will be 60. So this is the thing I got here. Okay, now if you start calculating it, here this 0 and this 0 will get cancelled. Okay, 6 2s are 12, so it will come to 20. Okay, this you can calculate and slowly see it. Okay, this calculation takes time, and if people are pretty good in calculation, you can do the calculation further. If you do the calculation, the answer comes out to be 2.05 molar. Okay, the answer comes to be 2.05 molar. Okay, so here the only thing you need to check is directly percentage by weight, weight by weight was not given. So we had to calculate percentage weight by weight with the given data in the question. And this is how we can solve this numerical. Okay, now we have one more question. Okay, this question I have taken so that here you can solve everything. You can use all the formula and calculate the thing, because if you see the question, density of 2 molar ethanoic acid or acetic acid is 1.2 gram per ml. Okay, find percentage weight by weight, molarity and mole fraction of the solute. So first let me start with calculation of percentage weight by weight. How can I calculate percentage weight by weight when density and molarity is given? We know the formula. Molarity is equal to 10 into percentage weight by weight into density. Okay, percentage weight by weight into density divided by molecular weight of solute. What is the solute for me here? Ethanoic acid or acetic acid. Now you can do the calculation. 10 into what is percentage weight by weight given here? We have to calculate. Molarity has been given, so I will write molarity here. Okay, I will write molarity here and I will calculate percentage weight by weight. So I need to calculate percentage weight by weight. Density is given. Yes, density is given, divided by molecular weight of solute is not given. What is the solute here? Ethanoic acid. So we can try and find out the molecular weight of ethanoic acid here. Carbon is 12. 2 carbons I have, so it will be 24. 4 hydrogens I have, so it will be 4. 2 oxygens I have, so 16 plus 16 will come to 32. So if I add this, 8 plus 2, 10. Okay, so it is coming out to be 60. Okay, this is also 60 like urea. So divided by 60. Now you can calculate this. Okay, so how much will I get here? 1.2 into 10 will be how much? 12. Okay, so if you cross multiply, you will get 12 into percentage weight by weight is equal to, I am doing cross multiplication here, so will be equal to 120. So here if I calculate percentage weight by weight is equal to 120 divided by 12. So what will be the percentage weight by weight here? 10. Okay, how much I got percentage weight by weight? So what is the percentage weight by weight of the solution whose density is 1.2 gram per ml and molarity is 2? How much I am getting percentage weight by weight? Percentage weight by weight of this solution is equal to 10. Okay, percentage weight by weight of this solution is equal to 10. So this is how you can easily calculate. Only thing is you need to spend little time to calculate the molecular weight of the solute. But other than that, I don't think there is any confusion in doing these kind of questions. As long as you remember the formulas very properly, you need to memorize the formulas. Hardly it takes little effort to memorize the formulas, but once you memorize the formulas, the process is very easy. Okay, now next what should I be calculating here? Next I have to calculate molality. Molality. And what is the information given for me here? I have density and molarity. Now when I have molarity, how do I calculate molality? We need to use the formula which has a relation between molality and molarity. So which formula will I use here? Molarity is equal to, okay, when I was teaching, this was the third relation which I taught you people. Molarity is equal to molality into density divided by 1 plus molality into molecular weight of solute divided by 1000. Okay, so this was the formula I have told you. So just substitute the things. Molarity do I have? Yes, I do have molarity. Molarity is equal to 2. Molality, I need to find out what is the density here. 1.2. Density is 1.2 divided by 1 plus molality. I need to calculate what is molecular weight of solute with ethanoic acid, which I have already calculated it to be 60 divided by 1000. Okay, divided by 1000. Now what can I do here? Okay, now what can I do here? I can take LCM in the denominator part. Okay, so 2 is equal to 1.2 m divided by, I can take LCM in this part because it is 1 plus 60 m divided by 1000. I'll take LCM here, I get 1000 here. So 1, okay, 1000, so 1000 plus 1000, once a 1000 in the denominator, so this will be equal to my 60 m. Okay, now what can I do here? Now what can I do? I will do the cross multiplication part here. So this will come here. So 2 into 1000 plus 60 m divided by 1000 is equal to 1.2 m. Okay, is equal to 1.2 m. So from here how can I calculate? Okay, from here how can I calculate? What can I do here? What can I do here? What should I be doing here now? I already got this. Okay, I already got this relation. I got 1.2 m is equal to this particular term. Okay, now what can I do? Can I take this 2 here? Can I take this 2 here? Okay, check here. 1000 plus 60 m divided by 1000 is equal to, this I can bring here. Okay, this I can bring here. So how much will I get here? 1.2 divided by 2. Okay, 1.2 divided by 2 here. How much will I get here? This will be 0.6. This will be 0.6. Okay, now what can I do? Okay, now what can I do? I can again cross multiply. So 1000 plus 60 m is equal to 1000 into 0.6 m. So if I solve this, how much will I get here? 1000 plus 60 m is equal to, now 1000 into 60. How much will I get here? Here I will get it to be 600 m. Okay, here I will get it to be 600 m. 1000 into 0.6. Now I can take this 60 m over there. So 1000 is equal to 600 m minus 60 m. Okay, how much will I get here? 600 minus 60 is 540. So 540 m is equal to 1000. So m is equal to 1000 divided by 540. 0 gets cancelled. Okay, 0 gets cancelled. Okay, if you try to solve it further, you will get the answer. Okay, you can do it leisurely. Okay, if you calculate 100 divided by 54, your answer should closely go to 1.85. Okay, 1.85 molar. Okay, 1.85 molar should be your answer. Once do the calculation of 100 divided by 54 and check, you will get the answer to be 1.85 molar. This is how I have used the formula and I have calculated molality. Okay. I have calculated molarity by using this formula. Little mathematical things are there which will take little time, but it's fine. You people are good in math, so slowly, step by step, see that you get see that you subtract the similar terms which have a molality term in it, and then you can divide it and get the molarity. Okay, as long as you know the formula, it's only the effort to calculate. Beyond that, there is no complication in doing these numericals. Now, when you see the last one, it is mole fraction of solute. I just know, like 5 to 10 minutes back, I taught you how to calculate mole fraction of solute. Okay, I taught you how to do the mole fraction of solute, because you have your density, you have your molarity. Now, when you have your molarity, when you have your density, is molarity and density useful for you, or what can be useful? You can use our second relation. Okay, you can use our second relation. What is the second relation you can use here? Okay, where you have the relation between molality and mole fraction. What was the formula? Molality is equal to mole fraction of solute divided by mole fraction of solvent into 1000 divided by molecular weight of A. Okay, into molecular weight of A. This formula you can use and you can calculate the mole fraction of solute. What is mole fraction of solute here? XP. You have the molality because we already have calculated the molality. Okay. Okay, now mole fraction of solvent is not there in the question, but I told you when you need the mole fraction of solute and the solvent is not given, but you don't need to calculate mole fraction of solvent also. If you want later, you can calculate after getting mole fraction of solute. Similar pattern of question I made you do just 5 minutes ago, 10 minutes ago. Now this you can write it as 1 minus chi b, okay, into 1000. Now molecular weight of solvent. What will be the molecular weight of solvent? Here if he has given ethanoic acid. Ethanoic acid is an acid, so it will be in water only. Then only it can release H plus. So your solvent will be water. So molecular weight of solvent water will be 18. So you have everything. Now please take it as homework and do the calculation part for this, because we did a similar pattern of question just before. Same pattern of question. Because it is the same pattern of question, you try to do it by yourself. I told you how to do also. Okay, I told you how to do also. So these are different numericals we have done for a very good practice for concentration terms. Okay, I hope I have covered all the possible doubts in your mind of how to solve. I did step by step each and every step of the numerical, and I have shown you, because if I skip the steps later when you solve, no, you will be in a confusion. How did I get this? I only left what did I leave for you people is only to do the simple calculation part. Apart from that, I hope I have shown you everything regarding the relation between concentration terms. So with this, we end a very big topic of concentration terms, because this chapter is solutions, and you people will be wondering when will we go to Henry's law, Raoult's law, all that vapor pressure things. We will go, but when we go to those topics, you should have a very good grip on these topics. That is the reason I was very particular in doing concentration terms properly, so that if you have lot of grip on concentration terms, when I teach you vapor pressure, relative learning of vapor pressure, Raoult's law, Henry's law, deviations, you will not have any confusion, because you have lot of understanding now on all the concentration terms. With this, we wind up the topic of concentration terms in the chapter solutions. So when I meet you in the next session, we'll be starting a very important topic of the chapter, which is vapor pressure. Okay, under which category they come and all that we'll see in the next session. Hope you are loving all my sessions. Okay, hope you understood this session. I gave you a small homework to calculate mole fraction of solute here. I wish you do it. You should be doing it. Okay, till then, till the next session, I'll see you. Bye.